Hello, everyone. And this is a demonstration phase of the piece of code called RC2 button, where essentially we know that the user expect the user to enter allow two buttons per user, and somehow we need to filter out which button are which. So we have the usual. We're going to actually save the data, and we print the combined data, and then we have a parameter called button one, where essentially we use the AND, which is bitwise AND operation with the mask U up, down, left, right to figure out if any of the up, down, left, right buttons have been pushed. So we can save that in the button one. And then when we take the original data, we also filter 1, 2, 3, 4 with the mask of 1, 2, 3, 4, save button 2. And then we can have two parallel if we detect the button one was either up, down, left, or right, we print the data out. If we detected 1, 2, 3, 4, we print the button 2 out. Let's go into the detail how the filtering operation works. Okay, so first the data coming in from the RC100 virtual or real comes in as 10-bit data. This is from bit 0 to bit 9. So bit 0 corresponding pretty much to the button up, bit 1 corresponds down button, and so on. So up, down, left, right, 1, 2, 3, 4. So these are the buttons. And let's say the user happened to be pushing the left button and the button number 3. So whatever you push, the data set will have 1s in that bit position. The up, down, left, right mask is essentially just any time that you have the up, down, left, right position, the bit position 0, 1, 2, 3, or 4, the mask is essentially just have 1 in it. So therefore, when you take the example data here and you AND with the mask, bitwise AND, the 0 AND with 1 is 0, 0 AND with 1 is 0, 1 AND with 1 is 1. And you can see anytime you have 0 in either the sample example data or the mask, you're gonna get 0 as a result. So the Ocean data does have 1 for button number 3 or bit number 6, but because mask is 0 there, so 1 and with 0, you're going to give 0. So essentially, you can see that Ocean data may have a button information on button left and button right in it. When you mask it with up, down, left, right mask, the data on the button 3 get eliminated, and we only retain information on the button, whether it's up, down, left, right, or not. So that's how this was done to take care of basically filtering out up, down, left, right button for the button 1. Similarly, you can see that you can, and it's shown in the book too, if you use a mask for bit position 1, 2, 3, 4 here, which is another example for it, you see that you're just going to filter out only if the button 1, 2, 3, 4 are push. So we're ready to go now. Let me download this piece of code. So it ran. Turn it back on again. We go into the demo mode. Okay. So it's connected. So I'm going to push the up button only, and you see it show up, which is 1. Now if I push up and also the button 2, okay, so you can see the button up is 1 is filtered out. The button 2, which is 32 here, is filtered out. The combined data set, you can see here 33, which is 32 plus 1, 33.